going to talk about sampling distribution for sample means. Okay. Before that, I will talk about Central Limit Theorem. So this is the Central Limit Theorem. The Central Limit Theorem for the sampling distribution for the sample means states that the sampling distribution of sample means, which is a probability distribution of sample means, is bell-shaped in nature. So we have X bar on the horizontal axis. What is X bar? X bar is sample mean. So we want to forecast or predict a population characteristic such as a population mean, but the population size being large, we have no way to reach the entire population with limited time and resources. Hence, we will collect a simple random sample of size n, sample size. And determine the sample mean, okay, sample size, and we have a simple random sample of size n. Simple random sample is important. What does it mean? It means all samples of size small n selected from that population has an equal chance of getting selected. Okay, so that's what is a simple random sample. So we get many samples of size small n, and we get many values of X bar. Remember, there will be many samples of size small n drawn from a population. Okay, and every time we'll get the sample mean, and then we will draw a relative frequency distribution or probability distribution of the sample means. And Central Limit Theorem states that this will be a bell-shaped distribution, okay, with the peak or where the relative frequencies on the vertical axis we have probability, okay, or relative frequency, and this particular probability density curve, as you notice, is bell-shaped or normal, and this is called sampling distribution or probability distribution. Probability distribution of X bar. Okay. Now the central limits theorem states that the value on the horizontal axis for X bar, where the peak is the highest or the relative frequency is highest, this particular value on the horizontal axis is the center of this distribution. This particular value is given by mu X bar. Why mu X bar? Because it's a mean of the sampling distribution of X bar, and its standard deviation is given by sigma X bar. Remember, standard deviation gives you an average difference or deviation from the center, from the mean. From Central Limit Theorem is also called CLT. From CLT, mu X bar, the center of this sampling distribution of X bar, is equal to mu, is equal to population mean from which the samples are drawn. So you can now see the advantage of the sampling distribution if we collect many samples of size n, simple random samples, and draw a probability distribution of this x bar, we get a bell-shaped curve for the sampling distribution of x bar. Its center is equal to the population mean. This way we can get an idea about the population mean without reaching the entire population. Only from samples of simple random samples of size n, we get an idea from the sampling distribution where the center, where the relative frequency is highest, is equal to the population mean. Okay, that's number one. Number two, the standard deviation of the sampling distribution, okay, is equal to sigma divided by square root of n. Okay, so sigma x bar is the standard deviation of the sampling distribution. Standard deviation of sampling distribution. Again, standard deviation means what is an average variation of the sample means from the center, from the population mean. Okay, sigma x bar is also called standard error. It's an average variation of the sample means from the population mean. And sigma x bar is given by sigma divided by square root of n. I have already introduced you n as the sample size. What is sigma? Sigma is the standard deviation of the population. Standard deviation of the population. Since we are dividing the standard deviation of the population by the square root of the sample size, the standard error or sigma x bar will be less than the population standard deviation. So this is what central limit theorem for sample means is all about. It's a bell-shaped distribution. Its center, where the relative frequency or probability is highest, is equal to the population mean, and its standard deviation is equal to population standard deviation divided by square root of n. Do you have any question for me? If you have any question, you can always put it in the comment. I definitely read those comments and I will answer your questions. If you like this video, please give me a thumbs up. Okay, and if you like this video, share with your friends. And please do not forget to watch me tomorrow when I'll be back with an application of the central limit theorem. Okay, and thanks for watching, and please do not forget to subscribe to my YouTube channel by hitting the red subscribe button, and please click on the bell button, because that will notify you every time I upload a new video. And please do give me a thumbs up. That really motivates me. Thanks. Take care. Have a nice day.